Hello learners, in this class we will discuss problems on this analysis of plane sections with single reinforced. That means reinforcement is only at tension phase. In another class we will discuss the double reinforced T sections. Now we have seen the four cases given in the code for the moment of resistance. One is dF by xu greater than 0.43, dF by xu less than 0.43 to find out the moment of resistance of under reinforced sections. And then also if it is a balance section or moment of over reinforced section, then you can find out this limiting moment by considering the dF by t less than 0.2 or dF by t greater than 0.2. So we'll see four cases, four problems of the moment of resistance, and another two problems we'll discuss to find out the area of steel for the under reinforced sections when dF by xu is less than 0.43 and when dF by xu is greater than 0.43. So in the first problem, you see the width of planes is given 1500, effective depth 500, the depth of planes is given 90, and the area of steel is given 6 numbers 25 hours, and the grade of concrete and steel given. So first write down all the data. Now first you should to confirm whether the neutral axis lies in planes or in wave. So to do that, you have to find out your xu by d. Xu by d is equal to again the same formula given page 96 for the rectangular sections, single reinforced rectangular sections, but only in place of b put the value of df. This value is come 98.5, that is more than 90, and again this value is less than, so it lies in wave, and this is also less than the xu maximum. So now you assume for the wave calculations your df is less than xu maximum. Xu is more than df, it is confirmed, but less than xu maximum is not known, so that is being assumed. So now how to calculate neutral axis? The neutral axis can be calculated depending on the principle that we have already seen for single reinforced section as well as for the double reinforced section. The total force in compression is equal to total force in tension. Total force tension is equal to 0.87 Fy ST, and we can find out total force in compression in case of this your plane section, that is Cu is equal to 0.36 FCK BW into XU, that is for rectangular, plot 0.446 is taken as 0.45. So 0.45 FCK DF minus BW into YF. Okay. Now the second formula is taken, and YF is equal to your you have taken XU. Okay. I see what is being taken 0.15. What is YF? 0.15 XU plus 0.65 DF. So that comes in terms of XU. YF is equal to in terms of XU 0.15 XU plus 58.5. Now this is your value of Cu. Now if you compare Cu is equal to Tu, then you can find out the value of XU. Okay. I see XU value comes out to be 114.17 millimeter. Okay, 114 point and more than 90, so it is greater than this. DF lies in wave and is also less than this, but this is acceptable. There is a condition that it's acceptable if your YF should be less than DF or maximum DF. So again, by after finding value of XU, you calculate YF, and you should confirm YF is less than DF. Then only it is valid. So and XU is also less than XU maximum. Now calculate your dF by xu value. dF by xu value is 0.78. It means it is more than 0.43. If it is more than 0.43, so which formula is to be used for moment of resistance? That formula number G2.21. Okay, it is given here. Clause G2.3. So for dF by xu greater than 0.43, see the formula, this 0.36 xu by d, 1 minus 0.42 xu by d, and then BF minus BW YF into D minus YF by 2. So put all the values and then find the moment of resistance of the section. Okay. The moment of resistance comes 490.95 kilonewton meter. It will come Newton millimeter, divided by 10 to the power 6 will give you kilonewton meter. So these are the steps you have to follow for all the problems. Now see the second problem. In the second problem, the area of steel is given 3943 millimeter square. I think all other things remaining same as for this last problem. So you have to calculate the same thing. This is given 3943, 3950 it is coming. So now you can take this value of xu by d, calculate the value of xu by d, and you see that whether this value is less than df or more than df, and now it is coming 131.5. If it is 131.5, then it is more than this value of df. So it lies in wave. So if first confirm it lies in wave, then we'll come to the calculation of this 3943 given. There is some mistake here. Please do these mistakes. This is not required because it has been it is no requirement here. It is given 3943. Okay, put the value 3943 here, and also here you can put 3943. There's some calculation mistake. So you just calculate, it will come less. It will come more than this value, so it will lies in wave. Now let us go to this problem, that your tension is equal to compression. Here we have taken that your TU is equal to CU. Now the TU value is equal to 0.87 FYST, and we have taken 3943. So this is the TU. Again put YF is equal to 0.15 XU into 0.65 DF. We'll again find this value, and putting this value on CU. CU is equal to again this, that we have already seen in the last problem, 0.36 FCK BW XU. The force in due to the rectangular portion, then this is due to the flanged portion, BF minus BW into YF into 0.45 FCK. So by putting all these things and equating, we will find XU is coming 209.476. So if XU is 209.46 and is greater than the DF value 90, so that means this lies in wave, but this XU is acceptable provided YF is equal to less than DF. So calculate the value of YF. What the value of YF is coming? See, the value of YF is coming 89.921. So 89.12 means it is less than 90. So now your this XU is valid. Okay, and this XU is also less than XU maximum, that is 0.480 D. So 0.48 into 500 is 240. So XU is also less than XU maximum, which is 240 millimeter. Now calculate DF by XU. So DF by XU is now coming less than 0.43. It is very close to 0.43, but if you change some value, it will be less than 0.43. In the previous problem, it was more than 0.43. Now it is less than 0.43. If it is less than 0.43, you have a different formula given in the code. So see that formula in page number 96. If DF by 9697, if DF by XU is less than 0.43, so G2.2, G2.2 you have to use. So in that formula you put the values. There will be no YF. It will D minus DF by 2. Okay. So put the values and get the solution. It comes out to be 628.7 kN/meter. So you have to confirm two things: whether DF by XU is less than 0.43 or DF by XU more than 0.43. Another thing you should confirm. Has to confirm that neutral axis lies in wave, lies in planes. If it lies in wave, then it is less than XU maximum or not. If it is less than XU maximum, then DF by XU is less than 0.43 or DF by XU is more than 0.43. Accordingly, you have to use the appropriate formula is given in code to find out this moment of resistance. Next problem, see, in next two problems, see that the XU is greater than XU maximum. So in that case, you have to find the limiting moment. So depending on DF by D. So let us see the next problem. The next problem, again all the data given same. The area of steel has been increased. By increasing area of steels 8 into 285, you will find this value 4926, and then find XU by D 4926. XU by D is coming, XU is coming 164, is more than the value of DF. So lies in wave, and XU maximum also 240. 0.8 times 500. Now come to wave. Now first assume DF by XU is less than XU maximum, and the similar way you calculate these values. Calculate the values TU, okay. Calculate YF and calculate CU, and then compare TU is equal to CU. From where it is a linear problem, you can directly find the XU value. So XU value is greater than 100, but you see XU is greater than XU maximum because XU maximum was 240. XU maximum was 0.40, 240. So that it becomes a over reinforced section. If it is over reinforced section, then your moment of resistance is limited to the limiting moment of resistance. So if you are going to find the limiting moment of resistance, then you have to check df by d ratio. So df by d ratio is more than 0.2 or less than 0.2. That we have to check and find the moment of resistance. Now see df by d is less than 0.2. So less than 0.2 means the first formula will be used G2.2. So put the value of G2.2. Putting the formula and putting all the values, you can just get the maximum bending moment or ultimate moment. That is coming 649.205 kilonewton. Next problem, we'll see that df by d is more than 0.2. This was df by d less than 0.2. Let us take another example, df by d more than 0.2. So in this problem again, same thing is kept. 8 numbers 28.5. 120 millimeter thickness of this flanged and 500 millimeter depth. So in the earlier problem we have it was 90. So it was 90. Now it has been converted to 120. So everything remaining same. Only the planes thickness has been increased to 120. So you go on doing the same problem. Find out your value of XU by D, and then you find XU. Now XU is greater than DF, so lies in wave, and again XU maximum is 400. Assume DF by XU is less than XU maximum, and calculate the value of compression and tension forces, and equal these values compression tension to find the neutral axis. Now see, we have find TU. Again TU is equal to 0.87 Fy ST, and YF you calculate. CU, the same formula, you calculate the CU value, that is for this concrete and for the planes, for rectangular section and for planes part. Then YF is already given here. Now CU is equal to TU, you will find XU is coming 247. So 247 means it is greater than DF, and also it is greater than XU maximum. XU maximum was 240. So XU maximum was 240. So it is also greater than 240. It is greater than DF, it is greater than 20. So if it is XU is greater than XU maximum, it is over reinforced sections, then you have to find the moment of resistance as a subject, as a balance section. So the resistance of over section is limited to mu limiting. But to finding mu limiting, you have to find df by d ratio. Now df by d ratio is getting more than 0.2. If it is more than 0.2, you have to use the clause G2.2.1. So see that clause and then put the equation into position. Okay. So you put the equations. YF is equal to 0.15 XU maximum plus 0.65 DF, because XU is equal to XU maximum for limiting case, and then find the mu limiting for both case. Okay. So XU maximum by D is known to you, and here YF is equal to 114 and is also less than DF, and you find it comes 752 kilonewton meter. So we discussed the four kind of problems for this plane section, single reinforced plane section. Let us see another two examples where we will find the moment of resistance. Now all we have seen T beams, now go for L beam. Now L beam has planes given, wave is given, carries a working moment. Working moment means you have to multiply 1.5 to find the limiting moment. So 520 into 1.5, M25 and Fe 415. So you calculate the effective depth, because the overall depth is given 500 plus 100, flange is 1200, means this you can draw this diagram. So this is equal to 100. So you can draw the diagram, you can find out this dimension. Now BF is 1200. So 1200, it is equal to 100. Okay. And the wave part is given 200 and 500. That means this is 200 and this is 500. Okay. 200 by 500. Now if it is 200 and 500, the total depth is 600. So if the total depth is 600, then find the effective depth. 600 minus 25 is a cover, 5 by 2. The diameter of rod you can take and find this value. And the ultimate moment is equal to multiply by 1.5. That will give the value of MUD. So now we'll see the moment is given. So now you have to find out whether the lies in wave or in planes. So you have to find the capacity of the planes. You assume XU is equal to DF, and for a single reinforced sections, find the value of MU1. considering as a single reinforced rectangular section, find the value of ME1. And you see this value is less than the value of this moment. That means the neutral axis lies in the wave, not in planes. Because if it is planes, it should be less than this value. So now, if it lies in wave, then df by xu is equal to 3 by 7 or more than 7 or less than 7. That we don't know. So first assume df by xu is equal to 3 by 7. So we find xu is equal to 7 by 3 df. So once you find this value, then equate this compressive force is equal to tensile force. Okay. So now the compressive force due to moment, due to compressive force, that is 0.36 FCK BWXU, okay, and then this compressive force due to planes 0.45 FCK BF minus BW into DF, okay, that will remain constant, this force. So basically the moment is equal to force into the lever arm. Now this moment is the rectangular section moment we have discussed earlier also. This is a rectangular section plus a plus a planes, compressive planes, which is BF minus BW into this is the DF. Now what the moment? These are forces. What the moment? Moment is equal to this value XU is you have taken 7 by 3 DF. So 7 by 3 DF put in place of XU and D minus 0.42 XU. And for this is D minus DF by 2 is your lever arm. So put all these values on the equation and then find this is equal to, okay, what the value is coming. Now by putting all these is coming 780 kilonewton meter. Okay. So if it is 780 kilonewton meter, 775, what the value of total moment? Total moment is given 780. So neutral axis lies in wave and df by xu is less than 0.43 because the value is coming less than 780. So df by xu is less than 0.3. That means xu is greater than this. So from this you can know because comparing your moments. So this is the moment given 780, but this value is coming 775. So your df by xu is less than df or xu is greater than this value. Because if you take xu value is equal to same, because you are taking df by xu is equal to 0.43. So if xu value is more, then it will achieve 780. If it is less, it will be less than that moment given. So xu must be greater than 7 by 3 df. So now find out the value MUW, that is equal to MUD minus MUF. Okay, MUF means the moment of this plane section which is remaining constant. So the wave will take the rest value. So moment has two parts. One part is due to your planes, one part is due to the beam part. Okay. So now what is the AST? So we find this moment is this. So find out the value of ASW. Now B is nothing. B is your BW. Put all the values. So area of steel in wave. ASW means area of steel in wave. It comes out to 1193.1. Now what is the area of steel due to planes? You can find the force already found planes divided by 0.87 Fy. So this is the area. So total area will be ASW plus ASF. So one part is due to compression in the planes. One part is the compression on this your rectangular section in the wave. So you can find your values and XU maximum is 271.2. So you can calculate your XC. XU is equal to 0.87 Fy SW. Again, as a rectangular section, it's coming 239 less than 271. So all these things becomes okay. Now provide the steel only. So we have found 4309.01. So that steel is provided here. So this is the one kind of problem where df by xu is less than 0. So you should be very careful here because you are initially assuming df by xu is equal to 0.43. But when take is equal to 0.43, then you find the value is coming less than this. So that means df by xu should be greater than this value. So in first case is equal to means df is equal to xu is equal to df by 0.43. So it is not satisfying. So it should be less than that. And the second problem we'll find out in this problem, working moment again 500 kN, all the sections remaining same, and we'll find the similar problem. And you see first initial case that the moment of this wave, assume xu is equal to df, capacity of this your planes is coming 564 less than 750. That means neutral axis lies in wave. Now again assume df by xu is equal to 3 by 7 and do all the calculation as you have done in the previous problem. So how will get? Now CUW, that is the compressive force due to in wave. Means because of the rectangular section, and then for the planes, and then calculate the mu value. Now again put xu is equal to 7 by 3 df. Now you see what the value coming. This is coming more than this. More than this means xu shall be less than this. But df by xu is greater than 0.43. Then only you will find this value. So because df by xu greater than 0.43, this value is coming more than this. That means xu value is less than 7 by 3 df. So if df by xu is greater than 0.43, then you can put the value of yf. Okay, 7 by 3 df, yf you can put the value and find out the value of MUD. Okay, design moment. So put the second equation. So by putting the second equation G 2.2.1 and here it will be YF instead of your D minus DF by 2, you'll find it's coming YF. So YF already 0.65 DF into 0.15 XU and put that value and you can get the equation MUD and see the value coming. Okay, now this value coming this much and this MUD is equal to your moment applied. And from this it is a quadratic equation. From the quadratic equation find the value of XU, but it is valid provided YF is less than DF. Again you have to check YF is less than DF. 0.15 XU plot 0.65 DF. So YF is coming less than 100. So XU value is correct now, correct 215.38. So if the XU value is known, then calculate the value of compressive force in wave and then compressive force in planes and then total force is coming this, and total force divided by 0.87 Fy because total force compression is equal to total force tension. So it will divide the compressive force with the 0.87 Fy, you will find the area of steel and then provide the area of steel in this section. So we discussed the all the type of problems for this plane section. They are single reinforced plane section, and in one class we'll discuss double reinforced sections. With this, this class ends. Have a nice day.